You are standing in a crowd of 50,000 people. The stadium is pitch black. Then, right as the beat drops, every single wristband in the arena ignites in red at the exact same millisecond. To the fan in the seats, it feels like magic, a spontaneous, visceral connection to the music and the 50,000 people jumping beside you. But achieving that level of precision across a stadium is a massive engineering hurdle. Our intuition tells us the venue must be using the world's fastest Wi-Fi or a giant Bluetooth network to manage all those devices. In reality, a standard network would fail immediately. Modern protocols like Wi-Fi rely on a two-way handshake, where every device talks back to a router. If 50,000 wristbands tried to connect at once, the traffic would instantly crash the system. There is also the problem of human timing. Even if the network worked, a lighting operator manually pressing a button cannot consistently react fast enough to hit a millisecond exact cue on every single beat. To make the synchronization work at this scale, engineers had to move away from smart two-way networks and human reflexes. The actual solution is a much more reliable technology, radio frequency and infrared transmitters. These systems work because the wristband acts strictly as a dumb receiver. It functions like a tiny car radio, listening for instructions rather than trying to send data back to the booth. In this setup, the stadium center lighting console acts as the radio station, broadcasting a single master switch signal across the entire venue. The transmitters flood the arena with a single uniform instruction. Every wristband is tuned to the exact same frequency, so when the signal hits, they all respond instantly without needing an individual connection. By removing the need for the wristbands to talk back, engineers solved the capacity problem, allowing the show to scale to 50,000 devices or more with zero lag. But solving the network capacity is only half the battle. The lighting system still needs to know exactly when to fire that broadcast so it lands right on the drummer's kick. The solution to this synchronization problem is SMPTE timecode. To us, it sounds like screeching static, but to the lighting console, it's a digital clock tracking the show down to the individual frame. Weeks before the show, a programmer locks specific color commands to exact timestamps on this clock. They don't have to hit a button, they just place the cue on a timeline. On show day, that timecode signal originates from the drummer's laptop or playback rig, traveling down a standard audio cable to reach the lighting booth. This signal updates the stadium's computers 30 times a second. As long as the band plays along to their internal click track, the computers handle the precision, firing the light cues perfectly in sync with the live music. By letting the timecode manage the math, the system guarantees that 50,000 individual wrists flash with a precision that no human operator could achieve. This combination of radio frequency broadcasting and timecode precision results in a unified pulse that covers the entire seating board. But standard stage lights can already illuminate a crowd. Adding the expense and logistical weight of 50,000 separate receivers only makes sense if the effect offers something a spotlight cannot. Lighting designers use these receivers to treat the entire stadium bowl as a massive reactive canvas. Because there is a light source on every wrist, the designer can change the color of the entire venue in a single frame, turning the crowd into a textured surface of light that matches the show. Instead of just aiming lights at the fans, the designer uses the wristbands to integrate the audience into the lighting rig itself. It turns the cold, rigid mathematics of the timecode into a tool for emotional immersion. The result of this invisible technical architecture is the removal of the lag between the musician and the fan. 50,000 people act in perfect unison, locked to the rhythm of the stage. However, flooding a stadium with these powerful invisible radio signals creates a massive new problem for the production. With all those invisible waves flying around, how does the crew keep the lead singer's wireless microphone from picking up a local radio station? We are decoding the invisible highway of RF coordination next. I'm Ambrose, this is Rig Decoded, and I'll see you at the next sound check.